Good afternoon. I'm Alker from Alibaba Cloud ACI product team. I'm also a Kubernetes container contributor. This is my topic about reinforced Kubernetes image isolation in multi-tenant service. So let's start with our agenda. First, I'm gonna introduce different views of isolation existing Kubernetes and talk about the different isolation responsibility in every views. Especially the view managing the image. And then I would like to go through a little bit the implementation about both Kubernetes and community in terms of image isolation. We will see some drawback, and I will show you a demo to observe this and talk about how we fix it. At last, we will wrap up and talk about the future work. So let's begin. This is a typical Kubernetes class architecture. Often we see it as two parts of API server and nodes. But in terms of isolation, we divide it into three parts to better understand the different isolation in every views. So let's go through the views individually. The first view is API view. It provides features like namespace authorization and admission controller. The namespace feature provides a feature that separates resources to make different groups seeing different resource collection. It's quite useful to isolate the data of API server. And it also provides some authorization method like IBC to determine if a request is allowed. And last, we have admission controller. It will filter and make some change or deny a request. Those features make sure the data of API server is well isolated. However, what if the data is outside of the API server? What guarantees the isolation? We will see the answer in the following slides. So let's continue. We also decided there are two isolation in the nodes, which are static data isolation and runtime isolation. These two are in charge of the essential data for running a container, such as the image, root base, and the runtime support. These data are invisible to Kubernetes user, so it will be a potential isolation issue. For example, the Kubernetes user have no interface to control the image poured in cluster. And we have several solutions in runtime isolation like Runc, Kata, and Gvisor. So we don't talk about it in this session, but we lack of much isolation in static data isolation, especially the image. So we will talk more about the image in Kubernetes. Image actually is not a data of API server, so we can rely on the isolation of API view. So once the image was poured in a node, every user in that cluster can create a container using that image without further authorization or other stuff. So this is a very awful situation if a private image was shared or accessed by untrusted user. And although there is little protection like always pour admission, but it doesn't help much. So it seems a big issue to us. But we have to know why Kubernetes couldn't isolate image well before we fix it. So let's talk about the image management in Kubernetes. Let's see the illustration in the right. The Kubernetes actually doesn't manage the image itself, but leverage container facility through the container runtime interface. We have listed a few CI methods here. That means most of the image management is existing in the community and the CI. So we get to continue to figure out how the CI and the community works. Let's talk about the Kubernetes first. Kubernetes offers a fully NIST-based API, so multiple consumers can all use a single Kubernetes instance without conflicting each other. And the CI in Kubernetes actually is a plugin on Kubernetes, similar to Docker and Porch. The CI you also use a single NIST-base. The NIST-base name is K8s.io. So the isolation issue is very obvious to us. No matter what NIST-base you are using with Kubernetes, all the image managed within one single NIST-base, by which Kubernetes can distinguish the tenants at all. Any image pulled through CI is considered belonging to one single tenant. So a straightforward solution will be this. We pass the NIST-based info through the CI and fully utilize the NIST-based API Kubernetes provides. This simply matches Kubernetes NIST-base to the Kubernetes NIST-base. Then, any operation on Kubernetes NIST-base will only affect the counterpart in Kubernetes. So let's see a few changes to the API. These are image-related methods. We add a NIST-based argument to the every method. And besides that, we also change the container and the product-related interface, because we can create a container using an image across the NIST-base. And a few more interfaces I haven't listed here. So basically, this feature adds a new dimension to every method in CI, so it may bring up some issue. Before this feature, the GC procedure is quite simple. It lists the resource in single NIST-base and do the GC stuff. However, after this feature, we have to iterate all the NIST-base and aggregate the resource and do the GC stuff. The change with the current code is quite complicated. And furthermore, handling NIST-base is increase the complexity of the CI implementation, such as the CI have to know when Kubernetes NIST-base is add or delete. And also, we already use that feature in our inner version of Kubernetes emulator work farm. It still targets work in process in upstream. So we would like to raise some community attention to work things out. And after all that, is the problem solved? Actually, not yet. From what we found, there is a very interesting issue within the containerd that somehow images are shared across the NIST-base. We found a case that we can read a provided image from a different NIST-base just by pulling a fake image from a self-set-up Docker registry server, as long as we have the digest of the image. So before diving into the technical detail, let me show you the demo. These are steps of the demo. This demo is quite simple. Firstly, we pull an ordinary image and get the digest from the file system. Then we launch a program which implement a simple fake image server, which only provide image manifester with no actual image file. Then we add the digest to the manifest of the image server. And lastly, we do the polling. So let's see the actual demo. I have pulled that image beforehand. So let's check out. Oh, oops, I didn't start the Kubernetes. Let's start it. We have project, and let's check out the Namespace tool. We have nothing here. Okay, so far so good. Then we can see we have some contents in the Namespace one, and we can both get the digest of the image from the content subcommand or from the file system. So I have added the digest to the image server beforehand. Just these two verbs, I already just added that. So we launch this program. Sorry. So let's do the polling. Okay, it works. See here, we have used two different namespaces, but we still get the same part of the image from the namespace one, and without accessing the origin Docker registry server. We can see here, we have this one content, and this one also exists in the namespace one. So it seems to us some part of the image is shared across the namespace in Kubernetes. So this problem quite intrigues us. So we decided look into the principle of the image in the Kubernetes. So let's go through a little bit the structure of the image in Kubernetes. An image consists of a list contents, which basically are different types of files. To run a container, Kubernetes has downloaded those contents and compose them into root base. And technically, a container is either a tuple of root base or a JSON config that describes other contents with metadata info like size and digest. So from what we see in the demo, it's the contents being accessed from different namespaces. So let's just focus on the contents and see how the content work with the polling flow. The polling flow is quite straightforward. The CTR command, which is the command end of the Kubernetes, will pull the contents individually and write the contents into the Kubernetes. And Kubernetes then will save those contents into file system with the digest on their file path. Therefore, only one copy of the identical contents will save at the file system. So this is very likely. When seeking the contents, there's only one copy or identical contents will save on the file system. So let's keep that in mind first. And if we dive into the details, the CTR command actually gets the manifest of the image first. And the manifest is configured that tells us how many contents the image consists of. And then the CTR command will get the contents individually. So one thing Prometheus is before fetching the content, the CTR command already knows the digest from the manifest of the image. So to emphasize this premise, let's see the details. This is a current version of interaction with the Docker registry server to demonstrate the steps of pulling an image. We can see here when CTR is trying to get a manifest of an image, the register return the digest of the image in the step 1, and then the CTR command will continually get that the contents of the manifest by that digest in the step 2, and then the contents of the manifest is returned. So by this iteration, we finally get the whole images. And how does that to do with our problem? So let's get back to our problem. In the client end, when going to fetch that content, CTR will go to the containerd service to open a content handler with the digest. And then the containerd will seek for that content with the digest globally to check if the content is already existed. Remember, there is only one copy of all the identical contents. So it is very likely there is no boundary, namespace boundary check. And we believe this is, of course, designed for better performance. However, it's a multi-tenancy situation in our case. So ideal design is provide a feature that let user decide if share the contents across the namespace. So we developed this feature. With the help of the community, we finally merged this feature into the upstream, and the current containerd is able to specify the sharing policy by the configure file. And for those users who don't care about the image security, can use the shared policy for better performance. Otherwise, use the isolated policy for better isolation. So let's try the demo again and see how this feature works. We have to clean up this environment first. Okay, nothing left. We have to change the containerd file. We change it to isolated. Okay, restart. We pulling again. Okay, the isolation is worked. So let's wrap up what we have done with the reinforcement. First, we fully utilize the containerd namespace API to let CI manage the image in different namespace for better isolation. And second, we enforce the contents isolation by adding a new policy, which will provide contents being accessed across namespace. We also looking forward to do some enhancement with the reinforcement we have done, and also bring up some potential solution here. Since we don't share the image across Kubernetes namespace, we may still want a user create a container as quickly as possible when using public image. And the GC is quite tricky with the current code base, as we have multiple namespace for the image. For instance, when Kubernetes is trying to GC, CI implementation has to record all the namespace and aggregate all the resource like the space of the image and the snapshot we have used and do the GC stuff. And also, the CI implementation have no idea when a Kubernetes namespace is deleted or added. So we have to sync up those two kind of namespace. And some enhancements like image locality has been used, which will schedule port to the node where already has the image. We also have to address that. And the last and the most important thing is we need to convince the community. The image isolation issue is very important. We need to fix this kind of issue. We knew the harder multi-tenancy group of Kubernetes community is working on such kind of issue, but we wish that kind of issue can be of higher priority. And we looking forward to discussing with anyone who involved in this kind of issue. And that's all I have to say. Thank you for listening.
Okay, thanks for Mr. Lin's great presentation. Is there anyone who has questions? I think it is a great opportunity to communicate with experts from Alibaba Cloud. Yeah. Okay.
Why do we need the namespaces?
Pardon me?
Can you repeat the question? Yeah, just speak.
Oh, I see in the future work, you mentioned that you will work on the namespaces, but why do we need them?
Pardon me?
The future work, yeah, the second line. You said that you need to work on the namespaces, but why do we need them?
Okay. Since we didn't share the image across the namespace anymore, so if a user wants to use like a BusyBox image in the key's namespace, and another user wants to use BusyBox as well, in our feature we have repulled that BusyBox since we already isolated those namespace. So if we have nested namespace, these two kind of users can all share those kind of like public image namespace. So all the public image can store in this image, and all the child namespace can share those kind of image.
Thank you.
Anyone else? Oh, perfect.
Do you have any work in progress or any PR regarding the 2 points which are on the garbage collecting part?
You mean just the two?
So iterate over our namespace when GCing and the namespace lifecycle sync. Is there any code in phase of being merged, or is it still future work?
This is our future work. We didn't urge you to fix right now. Okay.
Okay. Maybe you can slide to your email address to show us. If anyone has questions, you can communicate with Mr. Lin with your email address.
Yeah, sure. So I will off the stage for a while. If someone want to, feel free to ask me anything.
Okay. Thank you, Mr. Lin again.